Okay, so I'm going to briefly explain why we can't have perfect tracking and noise rejection in a control system. So what I have shown here is a system where the input is the reference signal and the output is what we want the system to follow. And then I drew this Bode magnitude plot, and if you look at that, we can understand how the system responds at different frequencies. At the low frequencies, which is shown over here, we want the gain to be close to 0 dB, and this is called the tracking region, where I wrote that, because it allows the output to follow the input pretty closely. However, the noise is typically existing at higher frequencies over here. So at the higher frequencies, we want the gain to be much less than 0 dB, so the noise is like dissipated or attenuated. And this is the noise rejection region. The problem is that the goals conflict with each other, so the good tracking requires high gain and the good noise rejection requires low gain. So instead of trying to achieve both perfectly, we can design a system so that the low frequency signals pass through and the high frequency signals are reduced. And the trade-off that I just mentioned is a pretty key idea in control systems design, and why this Bode plot is really important.